السلام عليكم everybody. الصلاة والسلام على سيدنا محمد وعلى آله وصحبه وسلم. We're gonna go ahead and start. We're recording this session, guys, so we can just upload it online in case some of us missed this session, and also you can go over it for review. I want to make sure that everybody is on camera. I want to make sure I can see your face, please. Go ahead and get your camera ready. Be on camera. We need to see your face. Want to make sure you are working with us. Today, we're going to go over the SAT geometry review. That was the missing session. I want to make sure we complete this one. Geometry is a really big portion of the exam. It can make big difference with your score. I'm sure you're familiar with some of these ideas, but some of it might be a little bit new to you, or you haven't seen them before. So we're gonna go over that today. Please make sure you have paper and pencil. We're gonna try some of these problems. Also, you will need a calculator, especially a scientific calculator. That'll be a great idea. So we're gonna go ahead and start. Again, please get on camera. I wanna make sure we can see your face. If we can see your face, that means you may not be working with us. So here are the topics. I want to make sure that everybody can see the screen. You all can give me the thumbs up if you can see the screen, please. All right, so these are some of the topics that you're going to experience. All right, so these are the topics that you're going to try to make sure that you understand. Covering these topics, we're talking about triangles, we're talking about circles, area, and volume. These are some of the things that you need to know. Also, we're talking about, I think I'm missing an...
That's because I just took a shower.
We're talking about lines and angles. We're going to cover all of these topics. I'm not going to read them all. You can read them after the session. I want to make sure you cover all of this. Triangles and polygons. We will work also on circles, area, and volumes. These are mainly the big topics going to be covered under the geometry section on SAT. I want to go over some of the definitions that I want to make sure you are familiar with. What is a line? And how we name a line. That is, for example, a line can be named in two different ways, either with a lowercase letter, like here, line E, all right, or an uppercase letter, sorry, two letters actually. Like for example, this line here, we can call it this line here. We can call it line E or line ME or PE. Any two points on the line can be used to name the line. And we put the sign on the top here to show it's a line. Now, a segment can be named with any 2 points, but it has to be the end point. Like segment PE, it has to start with P, end with E, or E, end with P. Line has no length. We cannot measure the length of a line, but we can measure the length of a segment. So for example, here, segment PE has a length of, like, for example, 2 square root of 2. And again, segment, because it has 2 endpoints, we can measure it. Array, when you name array, you have to start with the endpoint, like array PE, start with P and go in the direction of E. And array EP, that's different. Start with E, go in the direction of P. So for example, I want to make sure that you understand the difference between them. All right. So again, the array has to start with the endpoint. An angle, the angle is a union of 2 rays. So if I have a ray like ray OD, all right, this here ray OD, this one, and then I have ray OC, this one here. So this here is the angle. So the angle is a union of 2 rays. I have this here is OD, okay, and this is OC. So this here is the angle. How we define angle again is a union of 2 rays, and it has the same endpoints, point O. And this will be the vertex of my angle. So that's angle DOC. To name the angle, I can call it DOC or COD. If a single angle just by itself, we can call it angle O. Then we're going to talk about the triangle. Triangle PEB. A triangle is 3 segments and have 3 vertices. Quadrilateral, that means 4 sides and 4 vertices. So that's, we talk about triangle, we talk about quadrilateral. The word quad means 4. So quadrilateral means 4 sides. When 2 segments are perpendicular, that means they form 90 degrees angle. When 2 segments are perpendicular, that means they form 90 degrees angle. Want to make sure you know that. And this sign here means perpendicular. You have a segment on the bottom like that and a segment on the top. This sign means perpendicular. And also I have another sign. I want to make sure you know it. I'm going to talk about it in a minute. This sign here means parallel. In case you didn't see him before, this is perpendicular and this here is parallel. Midpoint and distance formulas. If I have 2 points or a segment given on a graph, I want to find the midpoint. The midpoint is a point. So this is the formula for the midpoint. But simply, if you want to find the midpoint between A and B, you take the x's and average them, add the 2 x's and divide by 2, and take the y's and also average them, add the y's and divide by 2. So I want to find the midpoint. Go ahead and use paper and pencil. Find the midpoint of segment AB. Applying this formula, add the 2 x's, divide by 2, add the 2 y's and divide by 2, and tell me what is the midpoint. You can use the chat box to share with me.
Is it -1, 0?
Well, use the chat box so you can give a chance for other people to work also. All right. Thank you, Amir. How about the rest of you guys? This is just like a warm-up. I want to make sure you get into work with me. Find the midpoint for the given segment on the screen. Point A is 2 and -3. B is -4 and 3. Find the midpoint. I see here Ali also. Thank you, Ali.
One question.
Yes, go ahead.
Which point is point 1 and which point is point 2? So would point A be point 1 and point B be point 2, or does it really matter?
What do you think?
Honestly, I feel like it doesn't matter.
It doesn't matter. Name one, but order matters in a way that if B gonna be the first point, so this will be x1, y1, all right? You cannot say x1, y2, for example. It has to be the first point, so this x1, y1. Or you can call A is x1, y1. It doesn't matter as long as you keep in the same order. So this will be x2, y2. If you wanna go like this, that's okay. You wanna switch them over, that will be also okay. Remember, Ammar, I need an order pair. That means there is an X coordinate and there is an Y coordinate. All right. I see some of you switching the points up. Again, if you want to find x1 plus y1, add the x's. I'm going to add -4 and 2. So it can be -4 plus 2 divided by 2. And for the y's, I'm going to add 3 and -3. 3 plus -3 divided by 2. -4 and 2, they give me what? -2 divided by 2 give you -1. 3 and -3, 0 out. 0 divided by anything is 0. So that's the midpoint here. We add the x's divided by 2. We add the y's divided by 2. But watch out for the sign. All right. Now, I have to move quick so we can cover everything. If you have questions, please put the questions in the chat box, or we can discuss that a little bit more. All right. Now, regarding the distance formula. Now, to find the distance between 2 points, I use this formula, which is d equals x2 minus x1 all squared plus y2 minus y1 all squared. There are 2 ways to find the distance. One way is using this formula. The other way is using Pythagorean theorem. We use this formula or Pythagorean theorem if the numbers are small. But if you have big numbers, I rather use the formula. So in this problem here, -4, 3, 2, -3, these are small numbers. So you can use either way. Right now, I'm going to use the distance formula. Later on, we're going to use the Pythagorean theorem. So D equals, again, don't forget the square root. Don't forget there is a minus sign from the formula itself. So I want to make sure you see this minus sign here and this minus sign. So the formula itself has a minus sign. Go ahead and just apply that. Find the distance and share the answer in the chat box. I see some of the answers coming. If I didn't call in your name, that means I disagree with the answer. Remember, X2, we said we're gonna name whichever you wanna name him, all right? Any order you want, that's okay. So we're gonna call this here X1, Y1, and this will be X2, Y2. Order matters, guys. So we're gonna do X2 minus X1, that means you're gonna have 2 minus -4. You see, there's minus from the sign, but X1 also is negative. If you have a negative number, make sure you put it inside parentheses. Okay. Okay, let's go over this. I'm not really sure about the answer, Amir. Let's go over it together. Again, I'm just gonna apply this here. I'm gonna put this here on the top. So I'm gonna put D equals a long square root. You see, I have a negative sign here, and this is square, plus a negative sign here, and this square with minus sign. Just plug in. X2 is 2, right? So they're gonna be 2 minus X1 is -4. You'll agree? All right, and I have Y2 is -3 minus Y1 is 3. So 2 minus -2, the minus or negative added to positive. So it's gonna be 6 squared. Plus -3 minus 3 gonna give you also 6 squared. Is it right? No, sorry, 9, which is 9 squared. Hold on, that's wrong, right? -3 is -6 squared. All of that is under the square root. Is it right? So they're gonna give you 6 times 6 is 36, plus 6 times 6, 36 again. So give you a square root of 72. How many of you have this with me? Of course, you can use the calculator and find the square root of 72 if the multiple choices include decimals. If not, you try to simplify square root of 72. How would you simplify square root of 72? You're right, Aksa, thank you so much. You're right, Shifa, awesome job. I see here, Ryan, you have this answer the same like me, but I see some of you simplified the radical. You're right. What two numbers you multiply and give you 72? One of them is a square number. Let me go over this here and then you slide. If you want to simplify square root of 72, find two numbers, you multiply, give you 72. One of them is a square number. You remember the square numbers like 4, 9, 16. All of these are square numbers, right? 25 and so on. Of course, I can write 72 like you said, 8 times 9. Is it right? So they're going to be 8 times 9. Can I go bigger than that? It's 36 times 2. Awesome job. That is better. 36 multiplied by 2. So they're going to be, and then you break them up. They're going to give you square root of 36 multiplied by square root of 2. So they give you 6 square root of 2. So those who got 6 square root of 2, you're right. I didn't pay attention to that answer. All right, so either you have it as decimal, you find the decimal for square root of 72, or you simplify it. If you find the answer, the multiple choice are radicals. All right. Also, if you write square root of 72 as, like you said, 8 multiplied by 9, also I can break down the 8. So it's gonna be equal the same as 2 times 4 times 9. And 4, again, the square root of 4 is 2. The square root of 9 is 3. 2 times 3 also give you 6, square root of 2. Either way, you're going to get the same answer. Awesome job, guys. Okay, I'm going to move on because of the time. These are other topics I want to make sure we go over. We're talking about different lines and parallel lines and transversal. If these two lines are parallel, so this line here, we call it transversal. So the transversal is a line that cuts other lines. We call it transversal. In our case here, the two lines are parallel. So I want to talk about different types of angles here. I want to make sure I'm going to share this PowerPoint with you after class. We're talking about adjacent. Adjacent angles, any two angles, share one side and one vertex, and the other two sides are not the same. So for example, if I have two angles like this here, so this angle and this angle, we call them adjacent angles. Why? Because they share one vertex and one side, and the two non-share side, they don't have the same side. So these two angles here call it adjacent angle. Okay. However, if adjacent angle form a straight line, like instead of these two angles, if I straight this one here, so the adjacent angle look like this, like angle 1 and angle 2, we call them a linear pair. So an adjacent angle can give you a linear pair if they form a straight line. And in this case, the sum of 1 and 2 has to be 180 degrees. All right. So for example, if you add angle 1 plus angle 2, they give you 180 degrees. These are adjacent angles, but the non-shared side, they form a straight line, like line K. So if you add these two angles, call them supplementary. So keep in mind, supplementary angles, any two angles add up to 180 degrees. Either they are adjacent or not. But adjacent, they share the same. Like for example, if I have two angles, like this angle here and this angle here. If this one is 60 degrees, this one is 120 degrees. You see, these two angles, they are not adjacent angles. They don't share the same vertex. They have different vertex. They share nothing, right? But they add up to 180 degrees, so we call them supplementary. So supplementary angles could be adjacent and could be non-adjacent. Supplementary means they add up to 180 degrees. You will agree? But if they're adjacent and supplementary, that means they form a straight line. I want to talk about vertical angles. Vertical angles are angles that we call them head to head. Is it right? So I have two angles head to head, like angle 2 and angle 4. These two angles, when two lines intersect, they form two pairs of vertical angles. So vertical angles are two angles that head to head. All right, when two lines intersect, form two pairs of vertical angles. 2 and 4, they are congruent angles. But also I have 1 and 3, another pair of vertical angles. And vertical angles are congruent. So for example, if this one is 60 degrees, this one has to be 60 degrees. If this one is 120, this has to be 120. Is it right? Remember also, linear pair, they add up to 180. 60 plus 120 has to add up to 180 degrees. That's what we call linear pair. Right? A lot of vocabulary, right? Want to make sure we're familiar with that. Now,
congruent means they're the same. They have the same value, right?
Yes, the word congruent means they have the same amount, the same value. You're right, same measure. Right? Awesome. Yeah, I want to hear questions like that. That's awesome. I don't know how much you know about this or not, because we are in different levels, right? Some of us finished geometry. Last year was really hard in geometry. I understand. All right, so ask questions. All right, so now I'm going to talk about corresponding angles. Corresponding angles. Hold on, guys. This is a big issue. Corresponding angles. Now I have two parallel lines and transversal. Is it right? The transversal with the two parallel lines, create angle relationship. I'm going to talk about 5 or 6 relationships now. Pay attention what I'm going to say. The first one is corresponding. Corresponding angles are in the same location. So for example, angle 2 and angle 6, they are corresponding. They are in the same rotation. Like you see them, they are up, right, up, right. So that's 2 corresponding angles. Can you give me 2 and 3? You're right also. I like that, Muhammad. 2 and 3 are also adjacent angles. Can you give me another pair of corresponding angles? Give me another pair of angles that are corresponding. They are in the same location. Like one of them is a slide of the other one. Okay, 3 and 7, you're right. I see 1 and 5, you're right. Shefa said 3 and 7 also, you're right. So Ryan, Shefa, Muhammad, 4 and 8, you're right. So all of these are pairs of corresponding. It's like one of them is a slide of the other one. That's corresponding in the same location. How I know him? Like 2 and 6, we call him what? Up, right, up, right. Look at 1 and 5. 1 and 5. They're up, left, up, left. That's because I have the 2 lines here are parallel and I have a transversal. So that's the meaning of corresponding. Now, alternate interior angles. What's alternate interior? The word alternate that regarding the transversal. They are on opposite side of the transversal. That's alternating, right? So for example, angle 3, let me mark it, angle 3 and angle 5. We call them alternate interior angles. They are interior regarding the 2 parallel lines, and they are alternate regarding the transversal, one right, one left, but they still inside the 2 parallel lines. We call them alternate interior angles, and also they are congruent. If this one is 120, this also has to be 120. Can you give me another pair of alternate interior angles? Alternate interior angles. Give me another pair of alternate interior angles. Yep, there is one more pair only, which is 6 and 4 or 4 and 6. You're right. This pair here is alternate interior angles, and they are congruent. The measure of one of them equals the measure of the other one. Now I'm going to talk about seam. Before I move from alternate interior, let me talk about something I did right here. Alternate exterior angle. What are alternate exterior? Instead of the word interior, I'm going to say exterior. Well, the word interior and exterior, regarding the 2 parallel lines. Anything in between, we call them interior. Anything outside, we call them exterior. So look at angle 1 and angle 7. They're alternate exterior angle. You need to know the relationship because the questions on the test, sometimes they ask about the measurement, sometimes they ask about the relationship. What the relationship between 1 and 7? That's alternate exterior angle. Alternate exterior, all right? And also they are congruent. If this one is 120, this one is also 120. Keep in mind, I'm keep using 60 and 120 for a reason. Keep that in mind. Okay, I'm gonna summarize that at the end. That's alternate exterior angles. Now I'm gonna talk about same side interior angles. Like for example, angle 3 and angle 6, we call them same side interior angles, or sometimes we call them consecutive angles. What is same side interior angles or consecutive angles? If you see, like this one is a small one, this one is the big one. 6 is small, like 6, like 60, and the 3 is like 120. If you add them up, they give you 180 degrees. So that means they are what? Supplementary angles. Same side interior, and also the other word for same side interior, depending on the question, we call them consecutive angles. What are consecutive angles? They are on the same side of the transversal, but inside the 2 parallel lines. All right. The other thing is, what if I call it same side exterior angles? Same side exterior angles, like 2 and 7 is the same idea. 2 and 7 are supplementary. So remember, same side, they have to be what? Supplementary. They add up to 180 degrees. All right. But when we talk about alternate interior, alternate exterior, and corresponding, they all are equal. So when I say alternate interior, alternate exterior, and corresponding angles, they are congruent angles. But same side, they are supplementary. Why I need this? Because sometimes they're going to give you the measure of each angle using variables like algebraic expressions, and they want to find the value of X or Y or so. If you know these relationships, you can write an equation to solve for the missing variable. So here we talk about different relationships. Summarizing that, want to make sure you understand what adjacent mean, what supplementary angles mean, linear pair, vertical angles, alternate interior, alternate exterior, corresponding, same side interior, same side exterior angles. And we're going to apply that. And I move on. I have to move a little bit fast so we can cover all what we need to cover. Here we are. Look at this example here. That's from SAT practice. In the figure above, line L, and remember, line L and M, these are lower cases. That's how we name the line. There are two ways to name a line. So if this is a line here, I can call it line E, for example. You see, E is not a point on it, it's lowercase. But if I want to use points on the line, like I call it AB, you see, that's uppercase letters. So I can call this line AB, all right, or line E, either way of form. So when I say line E, I mean the line itself without using points on the line itself. Okay, so I'm going to move on. So I have line E and M. E and M are parallel. E and M. This one here is E, all right, and M. These two lines are parallel. So I'm going to put sign on them to show they are parallel. Sorry, that's line L and M. Line L and M are parallel. I'll use E for my example. Line S and T are also parallel. These two lines also are parallel lines. I'm going to do double arrows here to show they are parallel. All right. You're right, Hamza. So if angle one is 35, this here is 35. What is the measure of angle 2? What is the measure of angle 2? Since I have parallel lines and transversal, it seems like I have two measures only. You're right, guys. I see the answers coming. Ali, Muhammad, you're right. All right. I have two measures only. It's either angles, relationships. It's either equivalent. If you don't understand the last slide, just understand this one here. Like you see, I have only two angles here. One small and one big. You agree with me? All small angles are equal and all big angles are equal. And small and big together are supplementary. So like, for example, you see this angle here, if this 35, this one also has to be 35 because these two are small, right? But if this 35, what the measure of this one? They are supplementary. That means this one is 180 minus 35. 180 minus 35, they give you what? 145 degrees. So this is 145. That's it. So all the angles here you see, one of them 35, the other one is 145. I think that makes it simple. Anytime you have parallel lines and transversal, you don't have that much, options. It's just small angles are equal, big angles are equal, small and big, they are supplementary. So if this 145, this means this one is 145, this one is 145. But how you get from 35 to 145? Different ways. It's either you say that this angle here is 35, so this one here is 35, right? So this and this are equal. This 35, we get this are corresponding, this also are corresponding. And these two are linear pair. That means this one is 180 minus 35. Thank you so much for all of those who shared the answer with me. So again, it's so simple, but you need to find the relationships. Because some of the questions you're going to specifically ask for the relationship between angles. Now I'm going to shift to talk about different topics of SAT geometry, polygons. First, when I say a polygon, that one you see in the picture here, that is a regular polygon. What is a regular polygon? That all sides or all angles are equal. Yes, it is recorded. Okay. So again, all sides and all angles are equal. So if you know one angle, all of them the same. If you know one side, all of them the same. That's the meaning of the word regular. If I say regular, if I didn't say the word regular, that means I have no idea if they're equal or not. They may be different. Do not trust the graph. Sometimes we graph something, unless we give you information about it, you trust the words that are written or the sign on the graph. All right. So I have to say it's regular. So all sides are equal, all angles are equal. That means I know that this side equal this side, equal this side, and so on like that. And all angles are equal. Okay. What if it's not regular? That means angles may not be equal, sides may not be equal. How would you find the sum of the angles if it's not regular? Now I'm talking about non or just a regular, non-regular polygon. All right. So in general, to find the sum of the angles inside, the interior angles, you add up, subtract 2 from the number of sides. So I have here 6 sides, right? Subtract 6 minus 2. Right? 6 minus 2 is 4, and then multiply that by 180 degrees. So to find the sum of adding all 6 angles here, they're going to be 6 minus 2, which is the number of sides, minus 2. You always subtract 2. Why you subtract 2? Because really you're dividing this into triangles. If you want to count how many, use one vertex from here. This is one triangle, right? That's 180. This is another triangle. That's another 180. This here, another triangle. How many triangles here? 1, 2, 3, 4. That's 6 minus 2. So that's why if you want to find the number of triangles inside, each triangle is 180. That's why I multiply by 180. Subtract the number of sides minus 2, multiply by 180, give you the sum of the interior angles. But because it's regular, that means all angles are equal. So if you want to find the measure of each angle separately, you calculate 6 minus 2 multiplied by 180 and divide all of that by 6. Because there are 6 equal angles. 6 minus 2 is 4 times 180 and divide by 2. Does that make sense, everybody? So here I want to make sure you understand when I say regular polygon, that means all sides are equal, all angles are equal. How you find the sum of the 6 angles, interior angles? Subtract the number of sides minus 2. Is it right? Subtract the number of sides minus 2, multiply by 180. If it's irregular, divide by the number of angles or sides. They give you the measure of each angle. All right. Now, the other thing is exterior angle theorem. What is an exterior angle? If I have a triangle, these are the 3 sides of the triangle. If you take one side like AC, that side on the bottom, and extend it outside, that would form an exterior angle. So this angle here is the exterior angle. All right. This angle is the exterior angle. The measure of this exterior angle equals the sum of the 2 non-adjacent angles. We call them remote angles. So the measure of this angle here equals the sum of this one and this one. If you add these 2 angles up, equal this angle. So for example, if I know this one here is 40 degrees and this one here is 60 degrees. So what is the measure of the exterior angle? The measure of the exterior angle is 40 plus 60 give you what? 100 degrees. So the exterior angle equal the sum of the 2 non-adjacent angles. We call it remote angles, the ones that are far away. Can I move on, guys? Again, I can use this to write equations and solve for X. That's mainly the course of geometry. If you remember, a lot of writing equations using the relationships you learn from the figure. Any question about that? Could you explain the sum of all exterior? Okay, again, if I go back again. If I have, this is a regular polygon, that means all sides are equal, all right? Hexagon. The number of sides here are 6. The number of angles are 6. So I have 6 angles, they are equal, right? All angles are equal. If you want to find the sum of these 6 angles, you're going to follow the formula n minus 2 multiplied by 180. Why is n minus 2? Because that's the number of triangles you can form using one vertex from here. That's 1 triangle, 2 triangle, 3 triangle, right? So that means I have 1, 2, 3, 4 triangles. Each triangle is 180. So you multiply 4 times 180, give you the sum of the 6 angles inside. You don't have to do that on the test. All what you need to know is what? Find the number of sides, subtract 2, multiply 180. So that means you multiply 4 times 180, give you what? 720 degrees. That if you add the 6 angles inside, give you 720. If you want to find the measure of one of them, they all are equal and they are 6. So divide the 720 divided by 6. That will give you the measure of each angle inside. All right. Okay, can I move on? All right, let's apply that. I have this is a quadrilateral. Quad means 4. I want to find the value of x. Go ahead and use scratch paper and find the value of x here. Again, I can use the formula, which is n minus 2. But remember, these are not regular. So these angles are not equal. But I know 3 of them are equal, right? First, find the sum of the interior angles. That means n minus 2, which is what? N minus 2 multiplied by 180. All right? Okay, thank you so much. N minus 2 multiplied by 180. N is 4. That means 2 times 180 give you 360. So if you add these 4 angles up, give you 360. Let's add them up. That means x plus x plus x plus 45 give you 360 degrees. With the 3x is what? Just 3x, and subtract 45. You all agree? So they give you 3x equals 315. Divide by 3. Thank you so much. Thank you guys. You're awesome. Divide by 3. Divide by 3. Give you 105 degrees. All right. Thank you, Ammar. Thank you, Shifa. Thank you, Ali. Yaba. Thank you, Hamza. Try again. All right. So but look at the multiple choice. There is nothing, no 120 here. The whole idea is what? Find the sum. Of course, here I'm using quadrilateral. What if I use a pentagon or hexagon or any number of sides? Make sure you know what n is. Subtract 2, multiply by 180, and then you try to write an equation. I'm gonna move on because of the time. Another topic we're gonna work on in geometry, which is triangles. Okay, I'm just assuming you understand, you have an idea about this, just, you know, refreshing your memory. Isosceles triangle. What is an isosceles triangle? An isosceles triangle, yes, isosceles triangle is what? A triangle has 2 sides are equal. At least 2 sides are equal. So like, for example, this here, if this side equal this side, we call it an isosceles triangle. What's special about isosceles triangle? That means this side on the bottom, we call it the base. I hope you write that down with me. And this angles on the bottom, we call them the base angles. Base angles are congruent because the 2 sides are congruent, so the base angles are also congruent. So if this one is 40 degrees, this one also has to be what? 40 degrees. The base angles are congruent. So isosceles triangles, 2 angles are equal, 2 sides are equal. We call them base angles are equal. The one, the non-base angle, this is different. I want to make sure you know that, right? So the ones on the bottom are equal. All right, let's talk about all what I'm using here. We can use that to write equations. So make sure you remember that. Equilateral triangle. Equilateral triangle. Sometimes we call it equilateral, sometimes we call it equiangular triangle. Equilateral triangle is a triangle where all sides are equal. And that means all angles also are equal. If all angles are equal, so what the measure of each angle? Well, I know that that's a triangle that is 180 degrees. Hold on just a second. 180 degrees, is it right? But there are 3 equal angles. There are 3 equal angles, divide by 3, they give you each one of them is 60 degrees. So that's an equilateral triangle. All right, an equilateral triangle. If I have a segment, we'll call it the altitude, is perpendicular in this way, that is the height of the triangle, or the altitude divide the base in half. So if this is 5, this also has to be 5. And the same for isosceles. If I have an isosceles and I have the altitude divide the base in half. If this is isosceles, right? This side equal this side. So if this is 3, this has to be 3 also. So I want to make sure you know that that's the altitude. The altitude or the height is a segment that is from one vertex perpendicular to the opposite side. The height divide that only in what? In isosceles and equilateral triangle. I want to make sure you know that. Divide the base into 2 equal parts. I'm just giving you general information. Make sure you study that. You're going to use that to solve problems on the exam itself. Right triangle, that's the most famous part in geometry. A right triangle is a triangle, has one right angle. All right. The side, the opposite to the right angle, that's the longest side, we call it the hypotenuse. And the two sides that form the right angle, we call them legs. All right. So the side, the opposite to the right angle, we call it hypotenuse. That's the longest side of the triangle. And the side that form the right angle itself, we call them legs. And it has one angle. Triangle can only take one angle that is 90 degrees. Cannot take more than that. All right. They cannot take two right angles, for example. All right. So want to make sure you know, we're going to talk about that later on. All of the interior angles of a triangle equals 180. We talk about that. Is it right? For any triangle, the sum of any two sides, that's what we call it the triangle inequality theorem. Any two sides have to be more than the third one. For example, so if I have a triangle, that's in general, in any triangle, if you add two sides, have to be more than the third one. Otherwise, it's not a triangle. All right? So that's what we call the triangle inequality theorem. So for example, if I have any triangle now, let's call this side here A, this is B, and here's C. A plus B has to be greater than C. And also B plus C has to be greater than A. And A plus C has to be greater than B. The sum of any two sides have to be more than the third side. Otherwise, the two sides that are shorter than the third one, they are not going to meet together to form a triangle. We use this also to solve a problem. They're going to give you a range of numbers. So they give you a triangle, right? They give you two sides and they tell you, okay, which one of the options can represent the third side? Is it between 3 and 5, 6 and 8, and so on? So again, if you add the two given sides, have to be more than the third one. Area of a triangle is 1/2 base times height. Again, like here, this will be the base and this will be the height. If you remember the 1/2, a lot of students forget the 1/2 because again, the triangle is like half of a rectangle, right? Side length are proportional to the angles they are across. So that means bigger the side, bigger the angle. So if I have this here, you see A, B, and C, they are different sides, right? If A is the longest side, then this angle is the biggest angle. All right. So the angles depends on the side, the opposite to it. Bigger the side, bigger the angle. Smaller the side, smaller the angle. I know that's a lot of talking, but I hope that you can remember some of this here right now. Okay. Here are one of the items. Look at this triangle. I have the three angles A, B, and C. If angle A is 34, what is the sum of B plus C? Go ahead and solve this and share with me in the chat box. If angle A is 34, this one here is 34. What is the sum of this plus this? And that was quick, Muhammad. Awesome. Again, Ammar, this is simple. What you used here? What is the main concept I need to know to solve this problem? Thank you, Hamza, and thank you, Ali, Ammar, Ryan. Again, the concept, Shifa, if you add 140, hold on, some of us got, I have two answers now. If you add the three angles up, give you 180 degrees. That's the sum of the interior angles of any triangle, give you, you're right, 180. So you subtract the 180 minus 34, 10 minus 4 is 6, and 7 minus 3 is 4, right? 146 degrees. If that's the answer you have, okay, so that is the correct answer. Again, because all of them add up to 180 degrees. If you know one of them, subtract, give you the sum of the other two. You see, some of the problems are really simple like this, but of course, a lot of them will be more complicated than that. You have to write equations and Pythagorean theorem. The right triangle, again, is one of the most important concepts in geometry. Pythagorean theorem, I have, again, this right triangle. C is the hypotenuse, A and B are the legs. I want to make sure you know that. So A squared plus B squared equals C squared. That's if you don't understand where this comes from, just remember you have to memorize it. You will use it in SAT. All right. And again, the meaning of it, what? The area of the square that form on the hypotenuse equal the sum of the areas of the square form on the two legs. And I'm sure you've seen this before. You don't have to remember that in SAT. Just know that C squared equals A squared plus B squared. All is the opposite. A squared plus B squared equals C squared. When I use Pythagorean theorem, I use, if you study the course of geometry, there is a big section on right triangles and we make a map. All right, there are 4 or 5 different scenarios. What would you use depending on the problem? We use Pythagorean theorem if you are giving 2 sides and missing 1 side. So I'm giving the length of 2 sides, missing 1 side, we use Pythagorean theorem. Does that make sense, everybody? All right, so keep that in mind. So for example, if I give you a triangle, it has to be a right triangle, that's number 1. If I give you this one here is 4, and this one here is 10, how you find X? In this problem, I'm giving 2 sides, I'm missing 1 side, I have to use Pythagorean theorem. There is no angles involved other than the right angle. I'm not giving you one of the 2 acute angles. So I have to use Pythagorean theorem. How I use that? Again, the 2 sides that form the right angle, we call them A and B. The one the opposite to the right angle, we call him hypotenuse, that's C. You always know that. No, Pythagorean theorem only applies to right triangle. All right? Pythagorean theorem only applies to right triangle. If you don't see the right angle, you don't use Pythagorean theorem. All right? So for this one here, I have A squared plus B squared equals C squared. That means C squared minus B squared equals A squared. You all agree? This minus this equals this. So that means C squared minus B squared equals A squared. It's the same from here, but just I'm subtracting B squared from both sides. Just put the numbers. 10 squared is 100. Minus B is 4, that means 16. They give you A squared. Keep that in mind. 100 minus 16, you're right, give you 84. That means the A squared equals 84. And now pay attention to what I'm gonna do. This is the part a lot of students miss. A squared equals 84. Some of the students tell you that means A equals divide 84 by 2, which is wrong. A squared equals 84. If you want to find A, take the square root of both sides. That means the A equals the square root of 84. And again, depending on the multiple choices, if you see them as decimals, use your calculator and find the decimal. All right. If you see it as radical, simplify to find the radical. And again, I agree with you. You multiply 21 times 4, give you this one here. All right. So if you simplify this, they're going to give you square root of 4 multiplied by 21. I'm trying to come up with a square number. So see what square number can go into 84. That is 4. Is it right? And the 4 can get out as 2 square root of 21 if the answer is. That's how we simplify radicals. Simplifying radicals again means what? Find 2 numbers, you multiply and give you the number under the radical, called the radicand. One of them is the square numbers. What are the square numbers? There are 4, 9, 16, 25, 36, and so on. But you really need to memorize this. Of course, there is 1 here, but we don't use 1 because 1 doesn't change the value. So I'm trying to find which number 84 is divisible by. Is divisible by 4? Yep, 4 divisible by 4. So I'm going to use 4. So that's 4 times what give you 84? 4 times 21. Break it down. The square root of 4 is 2, and the 21 stay under the square root. So I want to make sure we understand how to use Pythagorean theorem and make sure you understand. If you are lost in the test, you can take all the multiple choices, use your calculator, convert them into decimals. But they're going to be really a lot of time. But if you don't know how to simplify radicals, but get familiar with that. There are videos on simplifying radicals on YouTube. Make it a lot easier. But again, simplifying radical means what? Find one of the square numbers can go into the radicand, the number under the radical. All right, another concept before I move here, there is something called Pythagorean triples. Like you see, I'm moving so fast, guys, because this is video. It's recorded. Make sure you can go over that again. But excuse me, I have to go fast a little bit. All right, Pythagorean triple. Any 3 numbers can fit this here. We call it Pythagorean triple. But there are famous ones, which is 3, 4, 5. Because if you square 3, square 5, 4, add them up, Take the square root, gonna give you 5. The other one that's famous is 5, 12, 13. You don't have to memorize them. If you can use c squared equals a squared plus b squared, you can make sure these numbers fit. All right, but if you remember him, I'm gonna add some more right now. We call them special right triangles. But if you remember this, that will make it a lot easier for you. Any triangle. So if you see a triangle have 3, 4, 5, or multiples of that, that means you can find the missing number so easy. All right. So for example, let me see that. I'm having a little trouble with my eraser. I don't know why. Come on, come on, come on. Okay. So for example, if I have a triangle, like this triangle here, again, it has to be a right triangle, none other triangle. If this one here is 6 and 8, so what this one gonna be? If this 6 and 8, so what the third one? What's the
10.
hypotenuse? 10. Does that make sense? Because again, the 6 is the same like 3, and the 8 is the same like 4. Just multiply by 2. So this will be the 5 multiplied also by 2. You see, or you divide by 2, or whatever, we call them the same ratio. If you have the same ratio of the 3 or 5, you can just easily find them. Why? Because this again save you time. All right, I'm gonna move on. Special right triangles. There are 2 special right triangles you have to know. We use this to find the answer using similar triangles. The 2 special right triangles, the 45, we call it isosceles right triangle. This side equal this side. Since they are isosceles and this 9 degrees, so that means these 2 are 9 degrees split in half. Each one is 45 degrees. All right. The ratio between them is 1 square root of 2. All right. So this 1 and 1, these are the 2 legs. So this is a leg, and this is the hypotenuse. That's only if you have isosceles right triangle, which is the 2 base angles are equal and each one of them is 45 degrees. Makes sense because this one is 90. The sum of the 3 angles is 180. Subtract 90 to remember this, as in which sides have those specific square roots. I'm not sure which one you're talking about, Ammar. Can be more specific. So again, I want to just memorize this. 1 square root of 2. Because again, if this one is 1 and this one, use Pythagorean theorem. 1 square is 1. 1 square is 1. 1 plus 1 is 2. Take the square root, give you square root of 2. So that really common sense, right? But just memorizing the numbers, 1 square root of 2. That give you the isosceles right triangle, 45, 45. All right. We can use this as ratio. So I can put here, and that's how I like to use it. Put here, again, that's the ratio, 1 to 1 to square root of 2. I'm going to see how we use it in a minute. The second famous right triangle, and listen to the statement I'm going to say right now, and you can write it down. It's 30-60 right triangle. If you have a right triangle, one angle is 30, and the other angle is 60 degrees. We'll call it special right triangle. Listen to this statement. The opposite to 30 is half of the hypotenuse. Opposite to 30 is half of the hypotenuse. That's why if this one is 2x, this one has to be x. You see, like this is 1 and this 2. The opposite to 30 is half of the hypotenuse. All right. And then the other leg gonna be square root of 3 of the opposite of 30. So the ratio of this one here is 1 square root of 3, 2. So remember, you have to remember this. This is a leg, hypotenuse. The hypotenuse is 2. The opposite, this leg opposite to 30. This leg opposite to 60. All right. So the opposite to 30 is half of the hypotenuse. And then you can use Pythagorean theorem. So if I have one like this here, that's if I forget, because this will not be given on the reference sheet. You have to remember that. The opposite, if this one is 30, so the opposite to 30 is half of the hypotenuse. So if the hypotenuse is 2, the opposite to 30 is 1. And use Pythagorean theorem. 2 square is 4. 1 square is 1. 4 minus 1 is 3. So this will be square root of 3. All right. For this one here, the 45 degrees. 45, 45, right? This 1 square is 1. 1 square is 1. 1 plus 1 is 2. So this is going to be square root of 2. If you remember that, that would be really helpful on the test. And this is what we call special right triangles. When we use these triangles, that if you ever see a right triangle with 45, 30, or 60, I recommend using this because that gives you the answer as radical. So you don't have to convert the answers into decimals to get this. We use this for special right triangles, and we use it with similar triangles. Look at this example here. Look at this example. They didn't tell me that much information about the sides other than this triangle. We need to find AD. The first thing I look at this that really got my attention is the 30-60. You see him? That's a right triangle. Each one of them is right triangle. And this angle is 30. That means this one also is what? 60. Is it right? So each one of them is a special right triangle. I can use a special right triangle because I'm giving the hypotenuse. Is it right? So since this one is 60 and this one is 60, these two base angles are equal. That means this side 12, this side also has to be 12. That's an isosceles triangle. How I know it's isosceles? Because the two base angles are equal. In isosceles triangle, the two base angles are equal. This one is 60, this one is 60. So if this one is 12, this one has to be 12. Right? If there are two equivalent angles, so that the opposite sides are also equal. And now that's a special right triangle. So I know the opposite to 30, this one here, is half of the hypotenuse. So if the hypotenuse is 12, this has to be what? 6. Because the opposite, if you can just remember this statement, can help you a lot. The opposite to 30 is half of the hypotenuse. So the answer, like you said, Ali, thank you so much, Ryan, awesome job. The answer is B, which is opposite to 30 is half of the hypotenuse. But how I know the hypotenuse is 12? I got my attention that this angle is 60, this angle is 60. These are the two base angles. If the base angles are congruent, that means we're talking about an isosceles triangle. So that means this side equal this side. All right? Okay. So I'm going to move on again. So again, you can solve it also in different ways, but I'm going to leave it like that. Any question before I move on? Remember, I studied the special right triangles, the Pythagorean triples, because I can use them when I talk about similar triangles. What similar triangles? I'll summarize that quick. Similar triangles are two triangles have the same shape but different sides. All right, one bigger, one smaller. That happened by dilation. All right. So if I have this A, B, C and A prime, B prime, C prime, that means this is the original one. Or we call it the pre-image. And the one has prime, that's the image. You always remember that. The one has prime is the image. Sometimes they give you the problem without the prime, just use different letters. Just I want to make sure from reading the problem, I want to know which one is the original. In the problem, they're going to tell you that, or they may use the prime naming. So read the problem carefully. You have to know which one is the original for similar triangles. Okay, what we know about triangles, similar triangles. If two triangles are similar, that every two corresponding angles are congruent. So that means this angle equals this angle. This angle equals this angle. This angle equals this angle. Keep in mind, in the test, they're going to take one of the triangle and rotate it, flip it, do something. You have to make sure you know how to name it from the problem itself. So for example, if I said that triangle ABC is similar to triangle GEF, for example, right? That's not here what I have. If we have a statement like this, how you know corresponding angles? You see angle A goes with angle G. These are two congruent angles. Angle B goes with angle F, all right? And angle C goes with angle, E. Angle C goes with angle F. So I want to make sure you know how to align, even though if one of them is flipped, rotated, gonna be confusing. Go back to the similarity statement, can align both angles and sides. I'm gonna show you the sides in a minute. But now, keep this here, I'm gonna talk about sides. Now, number two thing you have to know about similar triangles. If two triangles are similar, that means every two corresponding sides form the same ratio. I'm gonna call this side here number 1, and this number 2, and this number 3. This is 4, 5, 6, just for ease. If you divide 1 by 4, side 1 divide by side 4, that'd be the same as side 2 divide by side 5 that be the same as side 3 divided by side 6. So every two corresponding sides form the same ratio. All right, and that ratio, we're gonna call it the scale factor just in a minute. We're gonna find that scale factor. So number 2 is what? Every two corresponding sides form the same ratio. All right, how you know the corresponding sides? If the triangles are flipped, rotated, really I can't tell. Look at the statement. Like that statement he is giving. You see side AB goes with side EG or GE. Side BC goes with side EF. So I can write this statement here. Let me write here. That's how you know which ones are corresponding. AB over GE is the same as BC over EF. You see where I get that from? I didn't look at the graph. I'm looking at the statement itself. The statement will tell me exactly. All right. And then you have AC goes with GF. Of course, you only need 2 only, but I'm putting the 3 depending on the problem. AC going with GF. So you can align your proportion from the statement itself. And really, that's how you solve the problems more than the graph itself. All right. So we said number 1, every two corresponding angles are equal. Number 2, corresponding sides form the same ratio, which is proportional. All right. Number 3, I need to find the scale factor. The scale factor, I'm going to use S. F means scale factor. The scale factor, you divide the image by the original. You need to take 2 corresponding sides. Find which one is the image, which one is the original. So for here, if I can divide the image here is this one, the one has prime. If you divide 4 by 1, they give you the scale factor. Remember, 4 is the name of a side. That's not a number, right? So if you divide 4, side number 4, divide by side number 1, that will give you the scale factor of this triangle. All right. So these are the 3 things you have to know about similar triangles. Can I move on? Okay. Here we are. One of the famous problems or problem that used several times in SAT, when they give you 2 parallel lines. So I'm telling you this line is parallel to this line, right? And I give you 2 transversal, but the transversal intersect one another, cut one another. Like see here, this is a transversal and this is another transversal. All right. If 2 transversal cut 2 parallel lines forming 2 triangles because you can intersect together. These 2 triangles, this one and this one are similar. That means I can use the proportion. Okay. So what I mean, let me see. If I'm going to just use numbers to represent size, but these numbers are not numbers, are just names. Let's call this here is number 1, 2, 3. And now what side corresponding to number 1? Number 1 looks like the longest one. You're going to go the longest one here, which is going to be number 4. So that means 1 goes with 4. All right. 3 goes with, again, that's like one of them is rotate to the other one. 3 goes with 5, this one here. And 2 goes with 6. You want to make sure you know how to align the sides together. So 1 goes with 4, that's easy. But look at 3 goes with 5 and 2 goes with 6. Because you take the small triangle was rotated 180 degrees. All right. So if you rotate this 180 degrees, 5 gonna go on 3 and 6 gonna go on 2 and 4 gonna go on 1. So that means I know that 1 over 4 is the same as 3 over 5 is the same as 2 over 6. And again, I'm not using this as numbers, guys. These are just, I'm naming the sides. All right. That's how we use similar triangle. When I use that again, I'm giving you that these 2 sides are parallel. These 2 segments or lines are parallel, cut by 2 transversal, and the 2 transversal cut each other. They form 2 similar triangles. And you can use that to solve problems. All right. So I'm going to jump. I'm not going to do this slide now. I'm going to go back to this one because it's next. Look at this problem here. And I copied this from the practice itself. We need to find, given this information, they told me the line L is parallel to line M. L and M are parallel. So I can put a sign here. I know they are parallel. Is it right? All right. And they told me what? AD is 12. They need to find the length of AC. I need to find AC. I should give you time to think about it, but we are tight a little bit, all right? So in order to do this, I want to look at AC. How can I find AC? The only way I can find AC, I see two parallel lines, two transversal, they form two triangles, right? I know these two triangles are similar. So I have to use some similarity here, but also I see one of them is a right triangle. That means both of them are right triangles, right? So I know if this angle is 90, this angle also is 90 degrees. So it seems like in this problem, if I want to find AC, if I can find AE and then find EC, add them up, that will give you AC. So well, again, I want to find this one here. I want to find this one here, add them up, they're going to give me all of AC. You'll agree with me? This is AC here, right? It goes from A to E. I need to find AE, find EC, and then add them up, give me AC. You'll agree with me? So let's see how I'm going to do that. Okay, look at the big triangle on the top. I know this side is 5 and this side is 12. It's a right triangle. I have two sides. All right, I have two sides. Hold on, Lydia. I think I disagree a little bit. All right, but hold on, stay with me a little bit. So again, I want to find AE, I want to find EC. AE is the hypotenuse of the big right triangle. I have a leg and a leg. So what would you use? We said that we use Pythagorean theorem in any right triangle that you're given two sides and you're missing one. All right. So if I call this here, call this one here X. If you want to find X, use Pythagorean theorem here. That means X squared equals 12 squared plus 5 squared. All right. I'm just finding AE so far. That means 12 squared is 144. 5 squared is 25. They give you what? 169. You'll agree? Take the square root, you write Aksa. That means X is 13. Why? Because I know that X squared equals 169, take the square root. So I know this one here is 13. Awesome, I'm getting close, guys, right? This one is 13. Really good. Now my job is to find EC. Well, EC, can I use Pythagorean theorem for EC? But look, AC, I only know this side here is 1. Is it right? This one. But I don't have the other one. I only have one side. I cannot use Pythagorean theorem. For triangle EBC, if you want to find EC, you cannot use Pythagorean theorem. You're right. Use a scale factor. You're right. Or use similar triangles. That's what you mean. That means these two triangles are similar. So I'm going to use something other than Pythagorean theorem. This triangle is similar to this triangle. I know all the three sides here. I know one side here. So align them together. Remember, we say what? Who can tell me that the proportion? If you divide 1 by 5, you see I'm going this one over this one. 1 over 5 equals what? I need the EC, right? So we start 1 from here. I'm going to take EC from here. Let's call it Y. That equals Y over what? Over 13. You're right, Aksa. You're really good. You see, again, this one is confusing a little bit. You see, these two triangles are similar. So take corresponding sides. I start with 1. 1 over 5. You see, these two are corresponding sides equals Y over 13. Start from the small triangle to the big triangle, or you can do the opposite. Just make sure you go in the same order, the same direction. I start from 1. 1 over 5 equals Y. Y is the EC, guys, right? Y over 13. From here, I can use cross product to find the value of Y. That means 5Y equals 13. That means Y equals 13 over 5. You all agree with me? So that 13 over 5, I can use it as find a decimal or something. All right? Which is going to be, just go ahead and divide 13 by 5. 13 divided by 5, that give you 2.6. You're right, Khalid. Thank you, Khalid. You're helping. So that means Y equals 2.6. Remember, I need to find all of AC. So AC equals what? The 13 plus the 2.6, which give you 15.6. Okay, so here I use Pythagorean. This is the type of problems in SAT. They want to use multiple ideas to solve the problem. Here I use Pythagorean theorem and I use similar triangles. All right, any question? Of course, we can solve this in other ways, but for the time, I'm gonna move on. All right, let me go back again to another the slide I skipped, this one here. This here we're talking about dividing a segment proportionally. I know the height of this triangle is 18. And this side is divided into 3 different pieces with the ratios x to 3x to 2x. The way I divide this, again, I'm assuming this is the height of the triangle and this one side. So if I have a triangle and I have the height, any triangle is not necessarily a right triangle or isosceles triangle. If I have a triangle like this one here, this side here is cut proportionally. If this one is x and this 3x and this 2x, that means this is proportion, guys. This is like a ratio. So that means the height also is cut with the same ratio. So this is also going to be x, this is going to be 3x, this is going to be 2x, but with a different value of x. All right, I can say, listen, instead of x, I should y, 3y, and 2y. If all of this is 18, you want to find the maximum height of the ball that can go here, I need to find the value of 3y compared with the 18 itself. Is it right? If you add the parts, they give you 1 plus 3 plus 2, they give you what? 6 different parts. So if you divide 18 by 6, they give you the value of each part. 18 divided by 6 is 3. That means this one is 3 times 3. The maximum here has to be 9. That what I used again, because I have a height here inside, altitude, and I have a side that cut by x to 3x to 2x. So that means I will use the same ratio, but instead of x, it's going to be a different number. So this will be y to 3y to 2y. If all of them are 18, find the sum of the parts, which is 2 plus 3 plus 1, that's 6. Divide 18 by 6, give you 3. Multiply each one of them. That means the y equals 3. But this is 3y. 3 times 3 is 9. You're right, Ryan. Thank you so much. Okay, I'm sorry, I'm moving fast. You can go back again and look at this step by step. Look at this problem here. Think about it. I'll be back in a few seconds. Think about this problem and tell me how to solve it. All right, it's getting hot here. I have to put the air condition a little bit. Are we good with time? We have about 45 minutes left. All right, move on. So how we solve this problem here? This is, look at the keywords given here, which is the word what? Regular. It's a regular polygon. All right, how many? 9 sides. That's 9 sides, right? So I agree with you, Ryan. Thank you so much. All right, so it's a regular polygon and it has 9 sides. I know all angles are equal. So remember, x is not an angle. X is half an angle. Is this right? X is half an angle. So how many angles? If I know this angle, divide by 2, give you x. You'll agree with me? So x is half of the interior angle. So if I know how many of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to find the measure of each one of these 9 angles and divide by 2, that give me x, because x is not an interior angle. So x is half of an interior angle. All of this here is the interior angle. Is it right? How you find the interior angle? We use the formula n minus 2 multiplied by 180, and because they all are equal, divide that by 9. All right, that means that we're not going to give me x, they're going to give me twice x. Keep that in mind. You're right, Axel. Now, what you're going to do after that, you divide by 2, right? That will give you what? 140 degrees. Because they're going to be 9. This will be 9, right? 9 minus 2 is 7 times 180 divided by 9, give you 140. Take the 140 if you want to find x, right? divide by 2. They give you 70 degrees. Because again, the whole angle here is 140 degrees. X is half of it. All right, so make sure you know that. There are, of course, other ways to solve this problem, but I want to make sure I use the most common way to solve the problem. What I see here, they told me regular, and it's polygon. It has 9 sides. Uh-oh, I remember the formula. N minus 2 multiplied by 180. They give you the total number of angles together, the sum of the interior angles. Divide that by how many angles? Because since it's regular, that means all angles are equal. And there are 9 of them. But keep in mind, X is not interior angle. X is half of the interior angle. That's really important to keep that in mind. All right, can I move on? I have to move a little bit quick. I want to make sure we finish before time. All right. Now we're going to move to another concept here. We're talking about arc. There is arc length and arc measure. So when I talk an arc, here is AB, this part of the circle, we call them arc. Okay, so to find, there are 2 things I want to know about this arc. I want to know the measure of the arc and the length of the arc. What the difference between them? The measure of the arc is an angle measure in degrees. The length of the arc using measuring units like centimeters, inches, and so on. The arc itself is part of the circumference of a circle. So that's when I say find the length of the arc. I'm talking about part of a circumference. But when I talk about the measure of the arc, I'm talking about degrees. So the measure of the arc is what? In degrees. All right. What is the measure of the arc? I want to differentiate between 2 angles in a circle. One angle, we call them the central angle. What is the central angle? A central angle is an angle that is formed by 2 radii of the circle. Like this angle here, that's central angle. The measure of the arc is equivalent to the central angle. So if I want to find the measure of arc AB, that would be 70 degrees. Because I'm finding that in degrees. The word the measure means in degrees. I want to differentiate between length and measure. All right, the measure of this arc AB is 70 degrees. By the way, AB, we call it minor arc because A and B, point A and B, divide the circle into 2 arcs, one small and one big. If you look at the other one here around, that is the major arc. If this one is 70, remember the whole circle is 360 degrees. If this one is 70, so that means arc ACB is 360 minus 70, give you 290 degrees. I want to make sure you do that. If you add the measure of all arcs in the circle, they give you 360 degrees. Okay? All right. So now, that's about the central angle. Now, the other angle, the form by these 2 sides here, like angle C, this angle here, we're going to call it inscribed angle. The inscribed angle is half of the central angle. So if this one is 70, this one has to be 35. That's what we call inscribed angle. So if you have the inscribed angle, you want to find the measure of the arc, that means the measure of the arc is twice the inscribed angle associated with it. All right? The measure of the arc is twice the inscribed angle. So summarizing that, any arc has 2 angles, has central angle that is equivalent and have an inscribed angle which is twice of it. So multiply the inscribed angle in 2, they give you the arc. All right, how you know the inscribed angle? You see, it starts from A, going to the opposite side, going back again to B. So this is the inscribed angle, this central angle. So that means central equals 2 inscribed. Right, central equals 2 inscribed, or the inscribed is half of the central. So the inscribed angle, let me write that down. Inscribed equals half of the central angle associated with the same arc. You see the arc here is AB. All right, move on. Look at this problem here. I'm giving you this beautiful circle. Again, I copied this problem from the book itself, from the practice. Thank you, Ammar. All right, so we need to find the value of X. It seems like the value of x is the same as the measure of BC, right? So the measure of BC is x also, because that's the central angle associated with it. If you want to find the measure of x, well, I have an angle here, but this is the inscribed angle for the same arc. I'm talking about arc BC. If I know this angle, multiplied by 2, that gives me x. Do you all agree? How we find the measure of this angle? Oh, I don't know how to find the measure of this angle, because I don't have any information about other than I know this angle is 20 and this angle is 20. So how you find the measure of this angle? If this one is 20 and this one is 20. Well, what if I connect AP? Look at triangle on the top here. Remember, all radii are equal. That means this equal this. So that's an isosceles triangle. And I said in the isosceles triangle, the base angles are congruent. So if this one is 20, so this one also has to be 20. And also the one on the bottom, that's another isosceles triangle. If this one is 20, this also has to be 20. That means the measure of angle A is 20 plus 20 is 40 degrees. All right, but we said that angle X is twice angle A. So if this one is 40, this is going to be twice, which is what? 80 degrees, because the central angle is twice the inscribed angle, not multiplied by 2, because you're right, A is 40, but A is the inscribed angle, which is half of the central angle. That means A is half of X. So if this one is 40, this has to be 80 degrees. All right. Again, what I'm using here is what? The inscribed angle is half of the central angle. I want to make sure you know that. This is recorded. You can go back again and revisit this because of the time. We want to finish before 12 o'clock. All right, gonna move on. Again, we're still talking about circle, and they give me two angles, angle X and angle Y. What we know about these two angles, they are associated with the same arc, arc AB. Well, here is the statement, write that down. All inscribed angles associated with the same arc are equal. Doesn't matter how many of them or how they look like. This angle here is inscribed angle for the arc AB. This angle here is inscribed angle for arc AB. That means these two angles have to be equal. So inscribed angles associated with the same arc, they all have to be equal. That means angle X equals angle Y. If you read the statements here, they tell you that the measure of, is this R more, greater? Of course, no. Is it less? Of course, no. Are they equal? Yes. Because inscribed angle associated with the same arc are equal. Keep that in mind. Any question, guys? All right. Here we are. This one is really good problem. Number 4. They give me this beautiful triangle. All right, in a circle. They told me that O is the center of this circle, right? Segment BC is a tangent. Segment BC is a tangent. What we know about the tangent? The tangent forms 90 degrees angle with the radius that associate with it. Opposite divided by adjacent. I'm not sure, but let's see. Okay, so here, this is the tangent here, right? And this is the radius associated with it. That means this angle has to be right angle. So any tangent form a 90 degrees angle that are perpendicular to the radius that associate with it. All right, when the tangent intersect with an angle 1 point, or you touch the circle in 1 point. If you draw the radius from that point to the center, that means I have a right triangle. So now I know I have a right triangle. All right, keep that in mind. So the tangent is perpendicular on the radius that associate with it. I have a right triangle. They told me that OB equals AC. OB, this one here, equals AC. Well, I know that OB also equals OA because that's a circle. All radii in the same circle are equal, right? So and equals 6. So if this one is 6, that means this one also is 6 and this one is 6. That's the information I have, right? Now they want me to find the area of the shaded part. Well, how I'm going to do that? That's a right triangle, and this is a shaded part. I have no way to find the area of this shaded part by itself. all right? Unless I can find the area of the non-shaded part of that triangle, and I find the area of the triangle itself and subtract them. You all agree with me? So here's my strategy. I need to find a strategy. How I'm gonna find the area of the shaded part? Find the area of the whole triangle. All right, that's my strategy. Find the area of triangle, find the area of triangle O, B, I don't know what's going on, C. Find the area of this triangle, and then find the area of that sector, this part of the circle that associate with 2 radii. Hold on, this is not working now. This here is a sector. Find the area of that sector, subtract it from the area of the triangle. So second number, that's number 1. Number 2, find the sector and then subtract them. They give you the area of the shaded part. You all agree with me? I hope I'm not losing you guys. I want you to stay on camera and ask questions if you feel like I'm going, you know, it's hard. Okay, so my goal is to find the area of the triangle first and then find the area of the sector, subtract them. Let's find the area of the triangle. Well, to find the area of this triangle, I need to find what? I need to find the 2 legs, because that's the right triangle, right? I have this one is 6, that's easy. But how about this one here? How you find this one? Well, I can use Pythagorean theorem. Is it right? I know this one here is 12. If you add all of this together, that's 12. And this is 6. So if I call this here x, that means x squared equals 12 squared minus 6 squared. Because that is a leg. The leg is the hypotenuse minus the other leg, all squared. I'm just finding the area, find the length of this side before I find the area, right? In order to find the area of the triangle, you have to find the 2 legs. I have one leg 6, I need the other leg because that's the base and the height, right? So that's gonna be 144 minus 36, all right? 144 minus 36 give you what, guys? Come on, start working with me. 144 minus 36 to give you 108. You're right. Take the square root of 108. But hold on. I see the answers all are radicals. Is it right? So what I'm going to do, I'm going to try to simplify 108. Find a number that can go into 108 from 4. I have 4. All right. You remember 9, 16, 25, and so on. What number can go into 108? Can I divide 108 by 4? Okay, or 36. Awesome job. So they're gonna be square root of 36 times 3. Because 3 times 30 is 90, 3 times 6 is 18, they add up 108. So they give you what? 6 square root of 3. You'll agree? In fact, I could get the same answer using special right triangles, because this triangle here, since this 6 and this 12, the only way this 6 and this 12, if this is 30 degrees, because that is what? The opposite to 30 is half of the hypotenuse. So this one is 30. So that would be what? 6 square root of 3. That's easy. You see, there are different ways to do this, but I know that x equals 6 square root of 3. Now, if you want to find the area of this triangle, you multiply the area equals 1/2 base times height. That means 1/2. I know the base is 6 and the height is 6 square root of 3. All right, this cancel, this give you 3. 3 times 6 give you 18. I touched something here. All right, hold on. What's going on? Sorry, guys, I have a big issue here. I don't know what's going on. So they're gonna be 18 square root of 3. I'm not sure, something's happening here. So I'm gonna write here, that means x equals 18 square root of 3. Sorry, not x, that's the area. That's the area of the triangle. So I know the area of all of these triangles is 18 square root of 3. Now I need to find the area of the sector, right? How you find the area of the sector? I know that the area of the whole circle is pi r squared. So this is step number 1. I did step number 1 here, right? Step number 2, find the area of the circle, the sector. The area of the whole circle is pi r squared. I'm having a thick issue. I hope this will work. The area of the whole circle is what, pi r squared. But remember, I know that this special right triangle, the opposite to 30 is half of the hypotenuse. This 30, that means this angle here is 60. You'll agree with me? So I know this one is 60. So the area of the circle equals the area of the sector equals the area of the circle divided by the central angle of this sector. So that means you're gonna take this here, multiply it. I'm having a issue. I think I have to stop this and restart it again, guys. Okay, I'm gonna I have a thick issue. I'm gonna stop the recording and I take just a minute to restart. All right, so again, the problem is a little bit complicated. My goal is to find the area of the shaded part. So my strategy is, I don't know how to find the area of the shaded part, but what I can do is what? Find the area of this big triangle, find the area of the sector inside, and then subtract them. Well, to find the area of the big triangle, I need the base and height. I know this angle is 90 degrees because again, the tangent is perpendicular on this. So I know that's a right triangle. I have two sides. This one is 12, this 6. I use Pythagorean theorem, find the missing side, which is 6 square root of 3. So I know this one here is 6 square root of 3, right? Now, I use the area, multiply 6 square root of 3 times 6, and multiply by 1/2. This is the area of my triangle, 18 square root of 3. So the area of this triangle equals 18 square root of 3. Now I need to find the area of the sector inside. Well, keep in mind, this side is 6, this side is 12. That is the opposite of an angle. That is half of the hypotenuse. That angle has to be 30 degrees. I'm using special right triangles. Well, if this 30, that means 60. In order to find the area of a sector, the area of a sector is part of the area of the circle. By multiplying the area of the circle by the central angle of that sector divided by 360. So find the area of the whole circle, multiplied by 60 and divide by 360, because that's the part of the circle itself. All right. So again, it's like the area of each sector proportional with the whole circle by using the central angle. So if you divide 60 by 360, they give you the sector only, multiply by the whole circle. So that means gonna be pi. Is it right? Multiply r is 6. That means multiply by 36, multiplied by 60. Is it right? Divided by 360. All right. So this 0 cancel this 0, divide by 60, you get 1, or the 36 divide 36, you left with 6 pi. So the area of this guy here is 6 pi. Does that make sense? So I know the sector equals 6 pi. Now I need to subtract them. That means the area of this shaded part equal the area of the triangle, which is 18 square root of 3, minus the area of the sector that inside the circle, which is 6 pi. Now look at the multiple choice. Which one has this? That is answer B. You'll agree with that? So again, just the problem is a little bit multi-step problems. And like you see, I use a lot of geometry ideas to solve this problem. So if you want to just, go back again, I would highly recommend going over this recording again because it's a lot of information. Okay, I'm gonna go ahead and move to the next problem. They give me that the circle above with the center O has a circumference of 36. Well, if this is the center, this point is the center of the circle, and this is the right angle, all right? That means I have two diameters, and the diameters are perpendicular. Is this right? If this 90 degrees, that means 90, each one of them is 90 degrees. That means this one is a quarter of a circle. If I want to find the measure, oh, you see here the word length. Remember I told you before, make sure we differentiate between the word length and measure of the arc. I'm talking about the length. That means I want to find this in inches, all right? Or whatever units, length unit. So if you want to find the measure of this, since I have this 90 degrees, the measure of the arc equals the central angle divided by 360, right? The center angle here is 90, divided by 360, multiplied by the formula for the circumference, which is 2 pi r. This formula is for the whole circle, the circumference of the circle. But this arc is part of that, right? That's in general. I'm just make sure you know this. I know that the whole 2 pi r is 36. So that is simplified. This gives you 1/4 multiplied by 36. I get this from here. This is 36 from the problem, the circumference. So that give you 9 length units. So you're right, Ryan, you're right, Amir, that is 9. It's like, this is quarter of the, I want to make sure you know this formula. If the problem is not 90, what if you have a different degree here? What if I tell you 30 degrees? So they're going to be 30 divided by 90, by 360, multiplied by 2 pi r. Remember this formula, you're going to use it to solve other problems. I'm going to move on. Here we are. I'm going to try to give you an idea of this problem, and then in this problem, this is a trapezoid. WXYZ is a trapezoid showing above. How much greater the area of this trapezoid than the area of a parallelogram with side length of A and B. So that means if I graph a parallelogram here, let's say this is a parallelogram, this one here, this also base is B. How big the trapezoid compared with the parallelogram? What the difference between the trapezoid and the parallelogram here? The difference between them is the area of this triangle. Is this right? If I can find the area of this triangle, that will be how big that triangle compared with the parallelogram. Sorry, that trapezoid is more than the parallelogram by the area of this triangle. You all agree with me? So my goal is to find the area of this triangle. One thing that got my attention is the 45 degrees angle. Once you see a 45 degrees, that means I'm going to use what? I'm going to use one of the special right triangle. Is it right? Because I see here also, I'm looking at the multiple choices, they all have radicals in them. All right. So that means I'm going to use a special right triangle. If you look at this here, so I want to find the area of this guy here. What if I put the height here? All right. Remember, this one here is A. All right. So this is A. And this is the height. This 45 degrees. You remember, if I have a triangle like this one here, if this is 45, so that means that the ratio is what? 1 square root of 2. Is it right? Or x square root of 2. Let's write here 1x, x square root of 2. So if you want to find x, I know this amount is equivalent to the A. Is it right? So that means I can use the A and the x to find the value of x, because that's a special right triangle. So that means the x square root of 2 is the same as A. That means the x itself is A divided by square root of 2. That means this height here is A divided by square root of 2. I'm sorry, I'm moving fast, I know. Again, what's my strategy for this problem? They tell me how big, like how much big, or how big the trapezoid compare with the parallelogram having A and B. Well, the difference between them is the triangle. If I find the area of this triangle, that would be how big the trapezoid, what the area added trapezoid from the program. To find the area of this triangle, I need to find the height and a base. To find the height, I'm using the 45 degrees. That's a special right triangle. If this angle is 45, that means the ratio is 1x, x square root of 2. The x square root of 2 is the same as a. So I form an equation, so for x, the x equals a divided by square root of 2. So that's the height. Now I need the base. Well, it's the same idea. So this is a divided by square root of 2. So this one is a divided by square root of 2. If this here is, let me write down here, because the two sides are equal. If this one here is a divided by square root of 2, so this one also gonna be a divided by square root of 2. You'll agree? But these two are similar triangles. So this one also is a divided by the square root of 2. That means the base itself is twice this. So here I have a triangle now. This is a triangle. I told you this, remember this 45 degrees. This is a, and this is a over square root of 2. This also a over square root of 2. This a over square root of 2. Add these two together. So they give you 2a over square root of 2. Now the area of this triangle equals what? The area equals 1/2 base times height. The base here is this one here. So that equals 1/2 multiplied by 2a over square root of 2 multiplied by the height, which is a over square root of 2. I'm only using special right triangles here. All right. Now let's simplify this. I know that 2a times a give you 2a squared. You all agree? Now, when you multiply square root of 2 times square root of 2, they give you 2. Times 2 give you 4. Simplify the 2 is 4, they give you 1/2. So the final answer is 1/2 of a squared. That's it, 1/2 of a squared. So that is the answer. Okay, so again, what's my strategy? The strategy here, the question, make sure you understand the question. They told me that how much greater the area of the trapezoid compared with the parallelogram associated with A and B. How much greater, that means I need to find the difference between them. The difference between the trapezoid and the parallelogram is that yellow triangle. So if I find the area of that yellow triangle, that will answer the question. Well, what caught my attention here is the 45 degrees. If you see 45 degrees, if I have a right triangle and it has an angle 45 degrees, that means I can use the special right triangle 1 square root of 2. So if you want to find the area of this triangle, you need a base and a height. So I use this as the base. And this is the height. Will that give me a small triangle 45 degrees? So this is half of the base only, and this is the height. To find this, I use the ratio. I mean, the A is the same as x square root of 2. I found x. So the height here is A divided by square root of 2. Now, remember this triangle, this side equal this side. So if this is A over square root of 2, this also is A over square root of 2. But I have another piece here. Is it right? So this also is A over square root of 2. So add these two together, they give you 2a over square root of 2, multiply by 1/2, base times height, they give you the area of this triangle, simplify, you get the answer. All right, we're doing really good so far. Look at this. This also is a common problem. They give you, this is a prism, but it's a square prism, right? Square prism, that means the base is a square. Do you want to find the volume? Let me again. Okay, they want to find the volume of the glass in this figure, the glass only. Remember, it's hollow in the middle. If you want to find the volume of the glass only, that means I need to find the volume of this only. All the way down. All right? So what would you do? I can find the volume of the whole figure. Is it right? And find the volume of the hollow part inside. This is the hollow. the empty space inside, right? Find the volume of this empty space and subtract them, they give you the volume of the material used. You all agree with that? We use that in real life application a lot. So my goal is what? To find two volumes and subtract them. I want to find the volume of the solid part, not the hollow part inside. So if you subtract the hollow part from the big figure itself, gonna give you the volume of the material used here, the glass itself. So here are my two steps. First, I'm gonna try to find the volume of the big figure. Remember that is 2 by 2 by 5. So the volume V equals length times width times height, which is 2 times 2 times 5. 2 times 2 is 4, times 5 is what? 20. That was easy. Now I need to find the volume of the hollow part. Remember, the thickness of the glass is 1/4 an inch. Is it right? So to find the volume, you have to subtract 1/4 from each side. Where I am. So remember, from these two, I'm going to subtract 1/4 from here, subtract 1/4 from here, from both sides, right? So they're going to give you what? 2 minus 2/4, they give you what? The inside here, this is going to be 1.5. And the same from the other side, this also going to be 1.5. So that means I multiply 1.5 times 1.5. That's the volume of the area inside part. So V2, let's call this V1. That equals 1.5 multiplied by 1.5, but it's the same height. The height doesn't change. Multiplied by 5. You're right, Ryan. So they're gonna give you 11 point, I'm gonna take your answer, 25. If you subtract this minus this, 20 minus 11.25, they give you 8.75. To subtract the two volumes. So the answer is 8.75, which is, does that make sense? Okay, Ryan, did you meant the whole answer, or you meant just the piece I was doing? 11.5, 75, 25, that's the area of the hollow part inside. If you want to find the area, the volume. The volume of the grass is the difference between them. You will get something like this in SAT. They always ask, but again, I don't know what figure you're gonna get, but you're gonna have the difference of two figures to find something. All right, move on. Almost done, guys. The last part, I want to talk about trig. All right, stay now. I need your attention because a lot of geometry teachers, they come at the end of the year, they don't have time to finish the trig. So I'm gonna go over this quick. In about 10-15 minutes, I will tell you everything you need to know about the trig for SAT. Dealing with right triangle. If I give you a right triangle, it has two sides, like this side and this side. I'm missing one, you have to use Pythagorean theorem, right? But what if I give you, and also we talk about special right triangles, right? But what if I give you a right triangle? It has one side and one angle. One side and one angle. Now that depends on the problem. You may use a special right triangle or you may use the trig. What are the trig? In any right triangle, the side the opposite to the right angle, that's the hypotenuse. Now, if you're standing, now we're done with the hypotenuse. Now look at angle B and C. The trig is different from B to C. If I'm standing on C, I'm standing here, right? The side the opposite to C, they're gonna be the opposite. Hold on. The side the opposite to C, we're gonna call it the opposite. And the side that close to C, they're gonna call it the adjacent. All right? So the three trig, now that's if you're standing on C, the three trig ratios that you know, sine C equals opposite over hypotenuse. Cosine C, hold on guys. Cosine C, I don't know why my stuff is not connected. And now it's working. All right, again, cosine C equals adjacent over hypotenuse. And the last one is tan C equals opposite over adjacent. You have to memorize that. That will not be given to you on the test. You have to memorize them. If you're standing on C, first you have to label each side. All right. If I want you to find sine C, you have to label each side and then use these formulas here. I think there is a way that you can remember that. I forgot what they call it, but just, you know, it's so simple. The sine is the first one. It's the opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tan is opposite over adjacent. Now, this will change if you standing on B. Hypotenuse stay the same, but if you're standing on B, this will be your opposite. And this will be your adjacent. So that depends where you're standing. So make sure you know which angle we're talking about, and then label each point. Yes, you're right, Aksa. I don't use that by my classroom, but if you remember, that was awesome. Aksa said that Soha, Kaha, Toa. All right, Soha, let me write down here. Soha, Kawa, or Ka, and then Toa. That is sine equals opposite over hypotenuse. Cosine equals opposite over adjacent over hypotenuse. And then tan equals opposite over adjacent. If that can help you to remember them, that would be awesome. But you have to know which angle, and you have to label each side according to the angle that you're standing on. Hypotenuse, stay the hypotenuse as it is. Okay. Now I use this one. If I have one side and I have an angle. All right, or I might give you two sides and ask for an angle. So any problem involve one of the two non-right angle, we may use trig. Here's an example. Look at this here. In this figure above, let me go back again. If angle A equals certain measure, you know, sine angle is the same. It doesn't matter if the triangle big or small, because the angle stay the same and cosine is the same. So these ratios are constant for any right triangle. It doesn't matter if it's big or small. So look at this here. In this figure, triangle PQR is similar to triangle XYZ. Similar, that means why? Remember similarity? We said every two corresponding angles are the same. Do you remember that? That means angle R is the same measure angle Z. That means the three trig ratios for R are the same for Z. We can use one triangle to the other because the angles are equal. Okay, so with versus, okay, okay. If cosine R equal this amount, cosine, I think that the pen is still working. Cosine R equal this amount. This is R here. They tell me what is cosine Z. Well, since these two triangles are similar, that means R and Z are equal. Is it right? So the trig ratios for R are the same trig ratios for Z. All right. So if cosine R equals 0.263, that means cosine Z is the same amount. Is it right? It's the same amount, which is 0.263. Does that make sense, guys? Okay. There is another law. I want to make sure that I think that will be the last one. Just my pen needs to be charged. Okay, let's see if it works now. Okay, this formula is really important. Cosine and angle equals sine and angle equals cosine the complement to this angle. All right. So for example, if I have a right triangle, if this angle here is 40 degrees and this angle is 50, all right, that means these two, because against right angle, these two angles are complementary. That means if you add them up, give you 90 degrees. So sine 40 equals cosine 50. So sine and angle equals cosine the complement of this angle. So if sine and angle equal cosine another angle, that means these two angles, you add them up, give you what? 90 degrees. So let's take an example. If sine x equals cosine 35, 5 degrees. What's the value of x? Well, sine an angle equals cosine the complement of this angle. That means if you add this angle plus this angle, has to give you 90 degrees. So that means 35 plus x equals 90. All right? That means x equals 55 degrees. Is it right? Where I get that from? Subtract 35 from both sides. So again, if sine an angle equal cosine another angle, that means these two angles have to add up to 90 degrees. Look at this example. That's really important. You're going to have a question on this on the test. All right. Let me give you another example. If sine x minus 3 equals cosine 2x plus 5, I'm just making this up. What is the value of x? Well, since sine an angle equal cosine another angle, that means if I add this angle plus this angle, they give me 90 degrees, right? That means x plus 3, x minus 3 equals, plus 2x plus 5, that has to add up to 90 degrees. That's how you solve it. And then you solve for x. So I want to make sure you know that. Everybody understand the idea? Now let's apply to this. Sine x equals cosine k minus x. I need to find the value of k. Well, that's simple. Since sine an angle equals cosine another angle, that means x plus k minus x has to equals what? 90 degrees. Is it right? That's it. That means this x cancel this x. That means k equals 90. Is it right? Okay. But now the answers are not in degrees. The answers are in radians. What radian means? The difference between radians and degrees, that radians, that is pi equals 180. Pi equals 180. Write that down for your notes. You need to know this one here. So if k equals 90, 90 is half of 180. That means k equals pi divided by 2. Because pi divided by 2 is 180. Divide by 2 give you 90. So the 180 is equivalent to pi. So to convert this one here, like we said k equals 90. Remember, that is pi divided by 4. That is 180 divided by 4. That's not the answer. That is 180 divided by 2 give you 90. That's the answer. Again, pi is 180. That's how it changed from radian to degrees. Pi equals 180. All right. The whole circle is 2 pi. If you take a circle, okay, this here, if you take an angle and go around, that's 2 pi. So half a circle is pi. All right. That means the 90 degrees is pi divided by 2. So the circle itself is, you see like that? That is pi divided by 2, pi divided by 2, pi divided by 2, pi divided by 2. Each one of them is right angle. That's the circle. Okay. So I hope you understand this with me. I really I wanted to do more about the trig, but just I summarized the important ideas that you need to know about the trig. It's really important before moving on. Here, like what, before you go, just want to make sure you understand this. So if I give you here, let's say 3, 4, and 7, for example. I don't know if that doesn't work, right? This has to be 5 in order to work. 3, 4, 5. Can you find sine C for me? Sine C, remember, if I'm standing here, that would be the opposite. And this will be adjacent, right? Sine C equals 3 over 5, the opposite over hypotenuse. And you can change that into decimal. If I want to find cosine C, they're going to be 4 over 5. If I want to find tan C, they're going to be 3 over 4. So I want to make sure you know how you find sine, cosine, tan if you give you some numbers of the triangle. Now, the other thing I want to make sure, what if you have, if you don't have the angle itself? Like, for example, if you want to find the angle, all right, if I want to see, so I can take from here, I said sine C equals 3 over 5. Since I don't know C, the sine can jump over here. You can use a calculator. That means C itself equal the inverse sine of 3/5. You know what that means, right? What happened here? Okay. You can use a calculator. This is a calculator. All right. There is sine, cosine, and tan. That's the regular. If you want to find the inverse, you have to click on second. And then you put here gonna be sine. The sine to -1, we call it the inverse. You're gonna see it there. And then put 3/5. All right. So if I do that, so I'm gonna put second and then sine, that give me the inverse, and put 3 divided by 5. That give me the angle is 36.80. Hold on, I did something wrong. So I give you 36.87 degrees, that angle here. Okay. Also, you can use, that's how you find the missing angle using the sides of a right triangle. It's 12 o'clock. I hope you learned something with me. I'm gonna post this recording on the WhatsApp. I hope you learned something. Please send me a text message. I really wish you a great luck with your test. SAT is really important. Please make sure you read the question carefully. Make sure you answer the question that is given. If they ask for X, you answer for X. If they ask for a measure of an angle, make sure you really exactly answer the question. Read the problem carefully. Do the problems you know first. Make sure you really understand that. I will post my phone now. You can contact me from WhatsApp, but also I will post my phone number. That's my personal number is 904-707-3044. If there's anything I can do, I really wish you good luck. Thank you so much for your hard work, and بالتوفيق inshallah. Thank you so much. Thank you. Any question? I will hang up here for a couple more minutes if you have a question. Thank you.
Thank you.